Hey, this is Stickman Tech, and in this 5-minute video, I'll explain what REST is. REST is an acronym for representational state transfer, and unlike what you might think, it's not a protocol or a standard. It's a set of 6 architectural constraints that I'll explain in this video. API developers can implement REST in a variety of ways, as long as it lives up to these architectural constraints. But before we get into the guiding principles of REST, let's make sure that we have the terminology right. Most applications today follow this architecture. There's a client and a server. You as the user interact with the client. Say you're on a website and you want to navigate to a new page. You click on the new page and now you want to retrieve the information for that page. So what the client does is that it sends a GET request to the server. The server retrieves that request and processes it, so the data is properly stored in some database that the server queries, and then it returns the information to the client in the format of JSON or XML. The client can then display that information. To put it simple, REST is a way to communicate between the client and the server, only using these HTTP requests. A common mistake that people explaining REST do is that they say that REST is equal to HTTP. This is not true. You need to follow the 6 guiding principles of REST to be able to call your interface RESTful. Let's go through the principles. Principle 1. Client-server. So this is what we just talked about. You should have a client-server architecture. The client and server should be separated. Principle 2. Stateless. The server should not store any session data. Communication between client and server is stateless. As an example, let's show how this rule can be violated. Say that you have an API where you can request a certain item. So the client requests item 1 and the server returns that item. Now you add an API call to get the previously requested item, and the server returns whatever the client asked for the last time. This is a violation of the stateless guideline, as every information needs to be contained inside the request. The correct way to handle this is that the client again asks for the same item. Principle 3. Cache. So, simply stated, every response should include whether a response can be cached or not. So, when the client requests item 1, the server then returns item 1 and a value of cacheable. Let's say it returns cacheable yes. Then the client knows that it can cache this item, and the next time that the client requests this item, it can just retrieve it from the cache. Principle 4. Uniform interface. This principle is the key differentiator between REST and non-REST APIs. A good way to think about this is the way that your mobile phone interacts with the server should be exactly the same way that your laptop interacts with the server. Different clients should interact the same way with the server. Principle 5. Layered system. This principle states that it should be a layered system that organizes each type of server into hierarchies invisible to the client. So say that our server relies on some other server to process a request. Well, this shouldn't matter to the client. In this way, we hide all of the underlying complexity that is required to process a request. Principle 6. Code on demand. This is the last principle, and this is an optional one, for a good reason that we'll come back to soon. It simply states that it can be possible for the server to send code on demand to the client, that the client can then execute. This of course poses some serious security risk, which is also why this principle is optional. So let's summarize the REST architecture. REST is a client-server architecture. REST is stateless. REST is cacheable. REST provides a uniform interface between components. REST is a layered system. REST optionally provides code on demand. And that was REST explained in 5 minutes. If you liked the video, please consider subscribing to support my channel. I'll see you in the next video.